So differential calculus is very important because most of the time we will giving the uh, uh, problems in differential form. For example, if you are given electric field is nothing but dv by dx, right? So it's a differential form. So you will be asked to get something in the form of for example, electric field is asked, or we are always worried about the rate. Rate means not the price but the rate at which object moves, or rate by which the quantity changes. For example, d by dt of some momentum is nothing but force, right? Yeah, so that's the case. So kindly go through these lectures once again if possible, and try to learn how to formulate few problems we will do, then we can just move on. Okay, few formulas very important. It will be useful in electromagnetic theory, EMT, statistical physics, statistics. Okay, then where else we can use this as electromagnetic? Okay, wherever differential forms, but mainly in EMT and electrostatics, sorry, statistics. D by dx of log x ln, okay, 1 by x. It is not 1 by ax. 1 by ax into a will come, so this will get cancelled, so 1 by x. Okay, this is derivative of ln a by x, which is minus 1 by x. Here, since it is in the numerator, it is 1 by a. This is plus, this is minus, this you know, root x, 1 by 2 root x. Now this is log f of x. The derivative of some quantity is 1 by x, so 1 by f, which is the function, into derivative of the function, into derivative of that particular function. Okay, please remember, don't miss this. Tan inverse find x by y. So here both this are variable. Variable means y is depending on x, or something, right? Like this you can write f of x, y is a function of x. So it's not x by a. What is tan inverse of x by a? 1 divided by a square. Okay, yeah. Then what we can do here, yeah, please kindly note this one as well as this one, and please don't cancel it out, y and y. No, this is 1 plus x square by y square into 1 by y. That means these are different terms. This is the differentiation of this particular quantity, x by y with respect to x. That's why it is 1 by y. Here y is considered as constant. Okay, partial derivative. Yeah, here also don't cancel it out. It is minus 1 by x square into the constant. Okay, so okay, fine. Then some few integral. This is tan x dx log sec x. Okay. In terms of cosec also you can write. Okay, that we'll discuss later. This one, integral 0 to infinity x to the power n e to the power ax dx minus ax dx. It is n factorial by a to the power n plus 1. This is the n, and this will be useful in our 0 to infinity hydrogen atom problems. Hydrogen atom problems in quantum mechanics, this is very useful. This is useful in linear harmonic oscillator problems, from where the space is from minus infinity to infinity. Now what is this 0 to infinity? 0 is the starting of the hydrogen atom. The radius starts from 0. That's why it is useful in hydrogen atom problems. Okay, then this is also same, hydrogen atom problems, this is same. Okay, we will just discuss x to the power 2n e to the power minus ax square, okay, into dx, root pi 2 to the power n 1 into 3, this is odd numbers, multiple of odd numbers, into 2n times 1, 2n times 1. For example, if n is equal to 3, you have to go up to 5, 1 into 3 into 5 to the divided by a to the power n plus half. What is a? A is the coefficient of x square, coefficient of x square. Alright, now this is minus infinity to plus infinity e to the power minus ax square bx plus c, very similar to the first one. Dx is equal to root of pi by a e to the power b square minus 4ac by 4a. Similarly here there is no c quantity is missing, right? C is down there, so you will remove c from here. So if c equal to 0, what will happen? B square by 4a. Okay, now here in the third case you will remove b quantity also. B is also not there, b is also 0, so you remove b also, you will get under root pi by a. Okay, yeah, this is also important. Integral f dash of x divided by root f of x is nothing but 2 times root f of x, 2 times root f of x. F dash of x by root f of x is 2 times root f of x. 0 to infinity e to the power minus ax dx equal to 1 by a. Now just the reverse of this is minus infinity to 0 e to the power minus ax dx is 1 by a. Now I think this is plus. Wait, let me check. I'll check and tell you. Okay. It must be plus only. Yes, plus. Yeah. So minus infinity to plus infinity, sine square x by x square is nothing but pi. Okay. Now from 0 to infinity, sine square x by x square is pi by 2. Please remember these two formulas also. Okay, now let us come to few problems. Now from statistics we can take one problem. Okay, let us consider internal energy. Internal energy equal to it is given by U equal to minus dou B by dou beta log Z. Now what is this Z? Z is nothing but anybody? Partition function. Just like wave function in quantum mechanics, we have partition function in statistical mechanics. Okay, right. Now what is beta? Beta is nothing but 1 by kbt. What is kb? Kb is Boltzmann constant. Okay, Boltzmann constant. Okay, fine. That is just we will discuss all those things when we are discussing the statistical mechanics, but just for the how the problems come, we just have to understand, right? For that purpose I am just writing Z is equal to ABC by beta. Now you have to find out what is the internal energy U. U is given the formula minus dou by dou beta of log Z. Now you have to find out what is U equal to. Yes, come on, fast. You can do it by yourself. I am doing it for me. Yes, I hope everybody has arrived at this particular answer, because we have discussed in the previous section this thing, formulas. D by dx of log what is this? This is some constant a by x. It's nothing but minus 1 by x, right? Sorry, this is plus 1 by x. Sorry, this is minus 1. This is minus 1 by x. Denominator, in the denominator. So here you have already one minus sign. This minus sign will go with this particular minus sign that we have. So we will get 1 by beta. Fine. Fine. Now suppose you have something like y is equal to x square. How do you find dy by dx? Immediately you differentiate dy by dx equal to 2x, right? Differentiation of this particular y with respect to x. Now suppose I have something like this, x square plus 2xy plus y square equal to some 0, or equal to y cube. Okay, so how from this equation, how do you find dy by dx? What is dy by dx here? Differentiate each term. You differentiate with respect to what? X. Okay, so 2x, the first one, 2x dx plus, here you have x and y, so that is equal to 2x 2y into dx plus 2x into dy, correct, plus 3 times y square. Here we don't have any y term, sorry, x term, so y square dy. Now bring the x terms together. Here you have dx, here dy, and this is dy. Okay, so dx times 2x plus 2y plus this is equal to 0, because here you have zeros. Now 2x dy times 2x plus 3y square equal to 0. Now is it easy to find dy by dx? Yes, dy by dx is equal to, send this to the other side, dy by dx, so it will be minus of, what is the dx terms? Dx terms are two x plus 2y divided by 2x plus 3y square. So this is the answer. So this is how you have to find out the differential forms of the equations. Now one question: the relation between the potential V and the space coordinate is given by e to the power x into sine of potential V plus V log x equal to 0. Now you are asked to find out E. Yes. What is E? Yes. What is E is equal to minus dV by dx. Any problem in differentiating? Let's do that. So what is given is e to the power e to the power x into sine V plus V log x, right? V log x equal to 0. Now first of all differentiate with respect to x is there, V is there, these are the variables. So what can we do? E to the power x, differentiate with respect to x, that is e to the power x dx, same differentiation. Then here sine V will be a constant, so sine V plus, now e to the power x will be constant, differentiation of sine V is nothing but cos V, and again one more term will come because nothing but that is dV plus V log x. Now we will consider V as constant, log x derivative is 1 by x into dx plus, now we will consider log x as constant, so that is nothing but log x into dV. Correct. Now bring the dx terms together. Here you have one dx term, here you have one dx term, so dx into sine V e to the power x plus V by x, right, plus you have dV term together, let us bring that, dV times e to the power x cos V plus log x, right. Now this is equal to 0 because here on the right you have 0. Now we need dV by dx, that's equal to minus of, bring the x terms, sine V e to the power x plus V by x divided by, what is the other term, cos v e to the power x plus log x. Now this is only dv by dx. We need e, that is nothing but minus dv by dx, which is nothing but, here you will not get a negative sign, which will be positive. Whatever here you have, you can write. One more example, you can do it. Let it be 1 divided by 2 root x e to the power y root x e to the power y plus x cos y. Okay, this is equal to 0. You are asked to find out dy by dx. See, I know these are elementary things for you, but why I wanted to go through these scratches, because later on you will feel comfortable finding the electric field potential at different points, then even statistics. This will be very useful. Okay, the answer I will give you. Answer is 1 divided by 2 root x e to the power y plus cos y divided by root x e to the power y minus x sin y, with a minus sign. Okay. Now you can take this as homework. Y is equal to e to the power x, and that is one question. Then y is equal to x to the power x, and y is equal to x to the power x to the power x. All these are homework, practicing. There's no homework, practicing. Now let us come to applications of differentiation. First and main thing is finding the maxima and minima. Maxima and minima. Maxima point is somewhere like this. Minima is something like this. The maximum point here. Okay. How do you find maximum and minimum? It is just by putting slope is equal to 0. Now how slope? At this point slope is 0, right? Straight parallel to x-axis. At this point is also slope is 0. What about this point? This not, slope is not 0. So what do you mean by slope? Slope is nothing but finding the fall of angle, or the angle between the points and the x-axis. With respect to x-axis we measure the angle. Now slope is nothing but tan theta. Tan theta is y by x, right? So slope is nothing but y by x. Okay. This is called a point of maxima. This is called a point of minima. Okay. Now how to check through theory whether it is point of maxima or minima. Now when you put slope equal to 0, you may get some points where slope is equal to 0. Now I have to check. For example, I am getting at x equal to a and x equal to b, I am getting the slope as 0. Now I have to check whether if at x equal to a and x equal to b, whether it is whether it is this point that refers, or whether it is maxima that refers to it, maxima or minima. I just want to find. So how is that being done? Means take the second derivative of the function with respect to x. Okay. If it is negative, if the second derivative of the function happens to be negative, then this is maxima. Okay. That means if you are putting, you already have the first slope. Slope means what? D by dx of f. If you take the second derivative of f and put x equal to a, and then if you are getting a negative value, it is maxima. Similarly, if you put the second derivative of f and this x at x equal to b, then if you are getting a positive value, then this is minima. Okay, fine. And what if you are getting d square f by dx square as equal to 0? The second derivative is 0, first derivative will be 0, and even second derivative is 0, then it is called a point of inflection. Point of inflection. Okay. Okay, fine. Now we will check. And this this is called stationary points. Stationary points. Stationary points, either maxima or minima. It can be either maxima or minima. Stationary points. Another term is equilibrium points. Equilibrium points. Wherever you find these terms, you must understand we are just finding the slope. Okay. Stationary point, equilibrium point. In somewhere you will also mention critical points. critical points. Or or stable or unstable points. Now what is this stable? Stable means minima, lowest energy. Unstable means maxima, highest energy. Okay, now why is it called stable? If this is the minima, if this point is the minima, if I have a ball, it will roll down, and it may roll down and come to this point, and then it comes back. Okay, so it will be always in this potential. So that is called minimum or stable point, means it does not go out of this potential. Now if you have something like this, if either in this direction or in this direction, if it moves, slight push we give, it will roll down and it will not come back, right? That is called unstable equilibrium points. Fine. Think. Okay, now let us come to, let us do one problem. F of x is equal to 2x cube minus 3x square minus 36x plus 2 equal to 0. Now just let us solve this question. Now first I wanted to find the first derivative, right? F dash of x. So that will be 6x square minus 6x minus 36 equal to 0. Okay, I have to put it equal to 0. First derivative should be equal to 0. Now this need not be equal to 0. This is just a function. Okay, so when I put first derivative equal to 0, so this must be your first equation. Okay, now from this I can readily take it to 6 outside and make it x square minus x minus 636, okay, equal to 0. Now this is nothing but what can this be? Minus and minus, so minus 3 2, so x minus 3 x plus 2, so x minus 3 x plus 2 equal to 0. So which means x equal to 3 and x equal to minus 2. Now these are the two points, equilibrium points. Unstable or stable equilibrium point, we don't know. We know that it is either stable or unstable, right? Now for that we need to find second derivative of x. Now when you do the second derivative, don't use this equation. That is not your second derivative. This is your second derivative. First equation is your first, this is your first derivative. Okay, don't start immediately doing this, that will not fetch you the answer. So how is that done? 12x minus 6. Okay, now put x equal to 3, x equal to 3, what you are getting, that is 6 minus 6, that is equal to 30. So which is positive. Positive means what? Positive is maxima or minima? Minima. Now we have another point, that is 12x minus 6 at x equal to minus 2. So that is minus 24 minus 30. Okay, so this is what? Minus. So this is maxima. So at x equal to minus 2 you have maxima, and x equal to 3 you have minima. So if you draw the graph like this, here you have like minus 1, this is minus 2, this is 1, this is 2, this is 3. So at x equal to 3 you have minima, right? So somewhere here it will be like this. Now at x equal to 2 you have maxima, so this graph will come, and when it reaches 2 it will have the maximum point somewhere here. Okay, so this is how your graph will look like. Now it need not be here above x-axis, it need not be above x-axis, it can be below x-axis also, depending on the function f. So that also you can check where is the exact position, that you can check by substituting the value here. Put x equal to 3 and x equal to minus 2 and check, you can get where it is exactly lying. Okay, we will discuss that. Find the, this is another application. Okay, find the frequency of oscillation when potential is given. Okay, how is that done? We will first write frequency of oscillation means like this is should be a for example v of x is should be equal to half kx square. Now why? This should be oscillating. For one has to oscillate, it should be in a the force should be equal to minus of some constant times the displacement, right? F is equal to example is spring, right? Only then it will oscillate. So the potential of an such kind of force is nothing but half kx square, right? Now what is v dash? V dash is equal to k times x. Now what is v double dash? Which is nothing but k, right? Now if you put, let us bring this here, if you put v dash equal to 0, which means x is equal to 0, that means at x equal to 0 you have a point, you have a equilibrium point. We don't know whether it is stable or unstable, but equilibrium point we have, right? For that we will, what you will do is, we will take v double dash of at x equal to 0. Now v double dash is nothing but k. V double dash at x equal to 0 also will be equal to k, which is a positive quantity. Now since it is a positive quantity, it will be a stable. Stable means something like this. Your particle will come down to this point and move up here, then again come back. That means it oscillates. Oscillation will take place only in stable equilibrium point. In unstable equilibrium point, since the particle will not come back, it will not have frequency. It will not come back, right? So it will not have frequency. So we cannot find frequency in an unstable equilibrium point. Now we have this particular quantity k is nothing but m omega square. M is mass, omega is angular frequency. Okay, m omega square. Now what is k? K we already know, which is nothing but v double dash. So we will write it as v double dash equal to k equal to m omega square. Now what we want? Omega square or omega. So which means omega is equal to k by m under root, k by m under root. Bring this m to the left, and it omega square is equal to k by m, and omega will be equal to under root k by m. Now then you can write what is k? K was nothing but our v double dash. So under root v double dash by m is nothing but omega. at the equilibrium point, at whatever equilibrium point you have, that is at that particular point. I am just writing it at x equal to a, just to give you an idea. Now let us do one problem. V of x is equal to minus a times x square plus b times x to the power 4. So what is this? You are asked to find out frequency of oscillation, if any. It need not be that there should be a frequency of oscillation. First of all, we have to check whether it is whether it has a equilibrium point. Definitely it will have some equilibrium points, but we don't know unstable or stable. If it is stable, we should find omega. This is the question. As an example, I can give this for you. V dash is equal to, just differentiate the minus 2ax plus 4 times bx to the power 3. Right here, this is, we have to put it equal to 0 and find the equilibrium points. Minus 2a, and just taking the x outside, plus, or you can take 2x outside, so minus a plus 2b x square equal to 0, which means one equilibrium point we already got, because something into something equal to 0 means if the inside is not 0, the outside what is present should be 0. So one point I have got, it is 0. Right. Now another option is minus a plus 2b x square should be equal to 0, which means x square should be equal to a divided by 2b, or x is equal to plus or minus under root a divided by 2b. Now we can do v double dash of x. V double dash of x is equal to what? Just take this equation, not the simplified equation. Simplified equation, please don't use, because we are simplifying it. That is not the actual equation that we have. V double dash is equal to minus 2a plus minus 2a plus 12b x square. Right. Now put x equal to 0, which means you will get v double dash is equal to minus 2a. This is a negative quantity, which means maxima. So you at x equal to 0, you are not going to get any oscillation. So you have to try it with x equal to plus or minus a by b. Now let us put x is equal to, first you can put plus and then minus, but here since it is x square, it doesn't matter. Square term will never be negative. So x is equal to plus or minus a divided by 2b. So minus 2a plus 12b, what is x square? X square is a by 2b, a by 2b, bb gets cancelled, this is 6, this is 1. So minus 2a plus 6a, that is equal to 4a. Right. So v double dash, we got it as 4a. Now omega is nothing but under root v double dash by m, that is equal to under root, what is v double dash? 4a. What is the mass? m. Mass will be given. Okay. So omega is equal to under root 4a by m. That's the